Hi, let's take a second look at vector addition using scalar components. If you recall, in the previous video we supplemented our look at this process with the tip-to-tail rule. As I said then, explicit use of the tip-to-tail rule is not necessary when using this method. I simply used the rule to make the explanation clear. At least that was the hope. In this video I want us to take a more direct approach. Here we have three vectors. The magnitudes and the directions are given. Remember, these angles are measured counterclockwise from the positive x direction. This vector is 112 degrees away from positive x-axis, coming this way. To add these three vectors, all we need to do is find the components of each. It is important that you be able to do this quickly without having to actually draw the components. So I expect students to be able to take each of these vectors and determine the components. To assist you in calculating those components, you should find the angle between each vector and the y or x axis, the acute angle between the y or x axis. So for example, for vector A, we can say that the angle between vector and the y-axis is 22 degrees. So you should be able to figure this out easily enough. If this is 112, then this is 22, or this is 68. So working with these angles in here, these acute angles, it should be easier for you to determine the scalar components. So we can do the same for this other vector over here. That's 10 degrees, that's 80 degrees. In many problems, you'll be given these angles in a more direct manner. You won't necessarily be given the angle measured counterclockwise from the positive x direction. So you need to be flexible. No matter how the vectors are given to you, you need to be able to find these angles, these acute angles, and then find the corresponding scalar components. Of course, this is 43, so that's easy enough to see, and that would make this 47. So for example, bx would be b sine of 47, and by would be b cosine of 47. If we look at ax would be negative a cosine of 68, and ay would be a sine of 68. Or if we work with this angle, ax would be negative a sine of 22, and ay would be a cosine of 22, and so on. So you should be able to do those calculations quickly. What is important is that you draw these vectors, you draw these angles, and then you need to show the calculation. So in class, we'll actually put those calculations in here. I hope that you can see that this is fairly simple. To make sure you're getting this, I'll run through this one more time and use a bit more visualization. So we're going to add these three vectors. So what we need are the components of each of them. So what we're finding, for example, for vector A, are the scalar components that go along these vector components. Again, when you're doing this, you don't need to actually draw these unless you really need to. If you really need to do it, fine, but you should be able to do this without actually drawing these vectors. Again, if you have to, fine. We look at vector B. Remember that when you draw your component, those components and the vector itself should form the sides and diagonal of a rectangle. So for example, for vector A, we can see that rectangle there. For vector B, we can see that rectangle also. And of course, for vector C, those are the components, and we can see that rectangle. So again, your diagram can begin to become a bit cluttered. So I don't require these vector components be drawn. Well, there are exceptions, and we look at those as they come up. So the corresponding scalar components for ax, bx, and cx are minus 2.43, 4.53, and minus 8.17. The corresponding y scalar components for a, b, and c are ay is 6.03, by is 4.23, and cy is minus 1.44. When you add these up, remember we're adding these vectors, so you have to add these up. This gives me minus 6.07, and ry gives me 8.81. So I can see those vector components. Then I can draw my little box, and of course the vector sum of these will give me my resultant, which will have a magnitude of 10.7. So I can just show that there like that. And this is then going to be at an angle of 124.57 away from here. To get that, first you're going to have to find the angle either between this vector and the y-axis, this acute angle, or the acute angle between the vector r and the x-axis, using the definition of a tangent. To get the magnitude of this vector, we use Pythagoras. So rx squared plus ry squared, square root of all of that. So I hope this is helpful. In class, we will practice this quite a bit. Okay, so bye for now.